Okay, so I'm going to have a go at making this next video for you on the energy system. I'm going to try and split this up into systems, and I might cover a little bit of continuum, but I'll do recovery definitely on another one. Okay, so energy systems. Now, first things first, you have a multiple choice set of questions. If you were in the tutorial with me on Friday, or you collected this pack from me, just pop me onto pause. There are 15 questions to answer on the energy systems. Have a little attempt at them for me. When you're ready, think you're all done, then just press play again and we will continue. Okay, good luck. Okay, so if you've finished them now, I'm going to click over. I'm going to have a little look at the answers. As always, grab a different colour pen. Have a little look at how you got on. If there are any problems, any errors you're thinking, then please just send me a message on Instagram, and I'll obviously have a look and comment back for you. Again, have your specs out next to you. Can you, when you're marking your questions, can you just indicate on your spec or a little notes page that you've got anything you think, right, I need to have a look at that, I wasn't clear. Similarly on your spec, highlight anything green you think, exams tomorrow, right, I'm ready to go with that now. I'm going to leave that now. Alright? Okay, so hopefully you did well with that. And like I said, if you've got any questions on why any of them answers are how they are, just send me a quick message. But we'll progress. I'm going to have a little look at Quizlet. Now, we're obviously going to do this in class. What I'm going to do is I'm going to pop up a key term, and all I want you to do when the key term comes on, press pause, see whether you can say a suitable definition. Anything that comes then up on the screen that you didn't manage to say, just write the key term down. And so I think the first one might be looking at is ATP, and jot down any additional points that you could use in a definition description of that particular key term. Okay, so your first one's ATP. So just pop me on pause after each one, press play when you're ready to go. It's a high energy compound. It's the only usable source of energy in the body. I mean, you could expand on that. You could tell me there's only enough for 2 to 3 seconds of activity, at which point it needs to be resynthesized. You tell me it's a molecule of adenosine with 3 phosphate groups. That breaking off one of them high energy bonds releases the energy needed for muscular contraction. Alright, next one. Just keep pausing me so you're going at your own pace. Next one is an endothermic reaction. So what is an endothermic reaction? Okay, it's a chemical reaction which absorbs energy. Alright, so where energy is needed to facilitate that reaction. You might also be asked to provide examples of endo and exothermic reactions. I know I did see that on one of the sample questions. So you could use here, when resynthesizing ATP, ADP plus phosphate group plus energy are required to resynthesize ATP. Alright, that's an endothermic reaction. See your next one then. Creatine kinase. What is creatine kinase? Okay, it's got A's at the end, so no prizes for guessing it's an enzyme, and it catalyses the breakdown of PC. Most of these enzymes, scientists have been really nice to us because they tell us what they do in the title, so it's nice. Remember, an increase in levels of ADP triggers the release of creatine kinase, which then obviously triggers the breakdown of PC. Okay, next one, PFK. What is PFK? Okay, PFK, then let's have a little look at it. PFK, again, is an enzyme, phosphofructokinase, and it catalyses the breakdown of glucose. You might want to take that further and say into pyruvic acid as part of glycolysis. Okay, next key term then. Exothermic. What's an exothermic reaction? Alright, let's have a little bit of a look at that. Exothermic reaction then. A chemical reaction which releases energy. Again, you might be asked to provide some examples of exothermic reactions. You could say an exothermic reaction is the breakdown of ATP. So ATP into ADP plus P plus energy. You could use the breakdown of PC. So PC, we know, is broken down by creatine kinase to produce a phosphate group, creatine group, and release have a little bit of energy. Right, make sure you've got examples for each of them. Next one, glycogen. What is glycogen? Okay, let's have a little look at that then. Glycogen is a fuel for anaerobic glycolysis. We could take that a little bit further. We could say glycogen is broken down then into glucose by the enzyme GPP, and then obviously undergoes glycolysis. Next key 10, ATPase. That is a nice easy one for us. There's A's, so let's have a look. We know it's an enzyme. It's the enzyme that triggers or catalyzes the breakdown of ATP. Next one, sarcoplasm. What is the sarcoplasm? Okay, let's have a look then. Sarcoplasm, it's the location of anaerobic respiration. It's on PC. What is PC? Got us to find that. Let's have a look at it then. PC. Oh, I don't seem to have anything. PC, a high energy compound. We could say there's enough of it in the muscles to last for 10 seconds of ATP synthesis. The breakdown of ATP is catalyzed by, PC is catalyzed by creatine kinase. We could say that the PC system has few reactions, that produces energy really quickly, that there's no fatigue and byproducts. Next one, glycogen phosphorylase. We just mentioned that one a little bit earlier, so let's have a look at that. Enzymes catalyzes the breakdown of glycogen into glucose. Next one, lactate dehydrogenase. So let's have a look at lactate dehydrogenase. Remember to just keep pausing me, saying it, and then pressing play to keep going with me, because obviously revision is not about just listening. Remember, it's about testing yourself, finding what you don't know, jotting down anything you want to revisit. So lactate dehydrogenase, enzyme which catalyzes the conversion of, oh, spelling mistake in there, pyruvic acid into lactic acid in the absence of oxygen. FFAs, what are FFAs? Okay, let's have a look at that together. FFAs are your free fatty acids. They can be used by the aerobic system. They produce large amounts of energy, but they're resynthesized quite slowly and they require large amounts of O2 to resynthesize FFAs into fat. Resynthesize ATP using FFAs, sorry. Pyruvic acid is produced at the breakdown of carbohydrates during glycolysis. Next one, mitochondria. Should know that from fiber types. Mitochondria, location of aerobic respiration. We have both the matrix and the cristae. The matrix is the location for the Krebs cycle, the cristae for the electron transport chain. Coenzyme A. Coenzyme A is the enzyme that facilitates conversion of pyruvic acid into acetyl coenzyme A. Acetyl coenzyme A, remember, then enters the Krebs cycle. Energy continuum. I'm probably going to leave them here now because I think we're going to start going into some of the recovery ones. Energy continuum then is the relative contribution of each of the energy systems to overall energy production. So you'll remember for energy systems, energy continuum, seeing graphs like this. Okay, so we know at the start of exercise, or we might see one like this. At the start of exercise, the predominant energy system is the ATP-PC system for the first 10 seconds. You see here 10 seconds, at which point the lactic acid system becomes the predominant system. Takes over for the next, between 10 and 180 seconds, at which point then the aerobic system now kicks in and provides the bulk of the energy. Obviously, the aerobic system can't kick in right at the start because you've got that delay for oxygen. Okay, so that's a really quick recap. I'm now going to take it from here. So, and a key thing to know about the energy systems, I gave you a mnemonic which was stab feet. Okay, so again, have a little practice of that. Write it down for yourself now. Do you know what that is? I would use that if I had to provide an explanation of the energy systems. Just make sure I've covered all the key content. So you're looking at site, time, I think the time the energy system lasts for, ATP yield, byproducts produced, F is fuel used, okay, the E then equation, the next D, EG of activities that would use that energy system. Could also use enzymes, it's up to you, and then your final T is type of reactions. I always think they're about the intensity. Right, if I mention all of them things, I'm going to provide a pretty good explanation of the systems. Okay, so my table I gave you in revision looks a little bit like this, and then obviously positives and negatives, advantages and disadvantages, or drawbacks, is another way of saying disadvantages. So beware for any of them kind of keywords in the exam questions. So let's have a little look now then at the ATP-PC system. We'll go through this nice and quickly. Okay, so to start off with, we've got enough energy stored in the muscles, ATP, sorry, remember, for 2 to 3 seconds. ATP, we break off a high energy bond between the adenosine molecule and one of the phosphates. It is facilitated by the enzyme or catalyzed by the enzyme ATPase. We end up with ADP plus a phosphate group plus energy. If it releases energy, it is what type of reaction? Exothermic, I hear you saying. Yeah, well done. And therefore that energy therefore is used for muscular contraction to generate movement. Okay, but you've carried on your activity. We're at 4, 5, 6 seconds, the ATP is gone. So we need to resynthesize that. So what's going to happen now is when, very clever this, it's all very clever, when ADP levels rise, it triggers the release of the enzyme creatine kinase. Now we know creatine kinase's job is that it catalyzes the breakdown of PC. So the PC now then is broken down into its phosphate, a creatine molecule, and releases energy. So again, we know it's an exothermic reaction. What we then do is we need to resynthesize the ATP, or another word for remake it. So what I'm going to do is I'm going to add this ADP to the phosphate group here. It's going to require energy in order to facilitate that reaction, okay, for that reaction to take place. So it must be an endothermic reaction, okay. So I've got my ADP plus my phosphate group plus my energy is going to produce ATP. Now you'll notice here we then would have the creatine left knocking round. So what we then do is we go back to the start. The ATP is then broken down by ATPase to make ADP plus P, and then this phosphate group here is added to the creatine to resynthesize the PC. Okay. Whenever you get the questions about advantages and disadvantages of the systems, so if I'm analysing and critically evaluating any of the systems, I always think about stab fees. So just think about things like, is the time it lasts an advantage or a disadvantage? Is its fuel an advantage or a disadvantage? Is the byproduct produced, the ATP yield, are they positive or negative? So I just kind of work my way through them. So I start to think here that it only lasts 10 seconds, so that's a disadvantage for me. But an advantage is that it's very, very quick resynthesis. Why? Well, because there's no delay for oxygen, because the PC is readily available in the muscles, it's stored there, there's no delay in transporting it. There are very few reactions, so no complex reactions, so again it's quite quick production. In terms of byproducts, well, there's no harmful byproducts here, everything is just resynthesized. I could also think about recovery, super quick to resynthesize the PC. Remember I said to you, it takes about 30 seconds to resynthesize 50%, and it can take up to 180 seconds to resynthesize 100%. So it's going to be ready to use again sooner. So you think about sporting examples, a boxer, when he, in between the rounds, he gets to sit down, he has his break in the corner, some of that PC therefore can be resynthesized in that break. A basketball player during timeouts, a netball player, a netball goal shooter when the ball is down in her defending court. So she gets them to resynthesize that them PC stores. A midfielder, when the ball goes out of play. And you can also think about tactics that can be employed to enable you to recover. So you think about Anthony Joshua, when he was fighting Klitschko, he just kept out of his way as much as humanly possible, didn't he, to allow for that recovery. You see footballers doing things like time wasting, so defenders, smashing the ball miles out, players going down pretending to be injured. So there's lots of ways that we can try to apply tactics and strategies to resynthesize this PC as well. All right. Your next system then, the lactic acid system. So now we're going into anaerobic glycolysis. It takes place now in the sarcoplasm. Okay. And we've got glycogen, which is its fuel, is broken down into glucose by GPP, glycogen phosphorylase. The glucose is then broken down into pyruvic acid, which we know, is our glycolysis, by the enzyme GPP. by PFK, phosphofructokinase. The pyruvic acid then, in the absence of oxygen, and we know it's absence of oxygen because it's anaerobic glycolysis, is converted to lactic acid by the enzyme lactate dehydrogenase. This system resynthesizes 2 moles of ATP. And obviously it's got the byproduct, the waste product of the lactic acid. It lasts between 10 seconds to 180 seconds. It's anaerobic. So if we then start to think about positives and negatives, well, straight away we think its major drawback is the lactic acid. We know lactic acid decreases pH, denatures enzymes, and is going to obviously start to inhibit reactions and therefore resynthesis if that builds up. We know when it builds up, the lactic acid builds up, that is termed obla. Fitter performers don't reach obla as soon as unfit performers like me. Its time, well, it's an advantage because it's much longer lasting than the PC system. And its quick resynthesis, as of 10 seconds, that system is ready to kick in and take over as the predominant system. ATP yield's an advantage, well, it's twice as much as PC. But a drawback is it's nowhere near as much as the aerobic system. It doesn't last anywhere near as long as the aerobic system. We know we've got that lactic acid. Another advantage might be it provides energy for high intensity, short duration, or duration less than 3 minutes is what I'd probably be writing. Okay, so lots of advantages and disadvantages to the lactic acid system. And then our final system is the aerobic system. So the aerobic system we know is slightly trickier. But aerobic system starts with aerobic glycolysis, and we know glycolysis is the breakdown of carbohydrates into pyruvic acid. But once we get to the pyruvic acid at the end now, because it's aerobic, there is a presence of oxygen as opposed to the absence of oxygen in the anaerobic glycolysis. And at which point then the pyruvic acid goes through a link reaction catalyzed by coenzyme A to produce acetyl coenzyme A. Okay. This acetyl coenzyme A then enters the Krebs cycle, so this would be our Krebs cycle. The Krebs cycle takes place then in the matrix of the mitochondria, and during the Krebs cycle then, which is the second phase of the aerobic system, the acetyl coenzyme A combines with oxaloacetic acid, okay, so combines, got that here, combines with oxaloacetic acid to form or produce citric acid. This is oxidized through a cycle of reactions, hence why it looks a little bit like this. Okay, the cycle of reactions and produces CO2 as its waste product. We know CO2 is a waste product of aerobic respiration, and hydrogen atoms, and enough energy to resynthesize 2 moles of ATP. So we've got 2 moles of ATP in aerobic glycolysis, 2 moles of ATP in the Krebs cycle. What happens then is the CO2 is obviously removed at this point, and the hydrogen atoms are transported into the electron transport chain and passed along the cristae, splitting the hydrogen atoms into hydrogen ions, which are oxidized, which we know means oxygen is added, to produce water, and is our final waste product of the aerobic system, none of which are harmful. The hydrogen electrons then are carried by either NAD, or pairs of hydrogen ions I should have said, carried by NAD as NADH2 to resynthesize 30 moles of ATP, and FAD as FADH2 to produce 4 moles of ATP. So the total yield of the electron transport chain is 34 moles of ATP, plus 2 for Krebs, plus 2 for glycolysis is 38 in total. This one takes place, like I said, in the cristae of the mitochondria. So if you had a little go at filling that in, right, seeing where the gaps are in your knowledge, we will be able to go and have a little look at the answers in a second. Just quickly, some advantages and disadvantages. Well, if you think about advantages, here, we can think about its ATP yield is significantly larger than any of the anaerobic systems. It can last much longer than any of the other systems, so 3 minutes onwards, right? So its yield is much greater, it lasts much longer. It has no harmful byproducts, again, another really big advantage. The byproducts we said are not harmful. However, some drawbacks, well, it can't be used at the start of exercise. It takes 3 minutes to kick in, because we looked at the fact that there's a significant delay, therefore, for oxygen. It has a number of complex reactions, so again, the resynthesis isn't quick. And the final advantage, I would say, it can be used for moderate intensity activity that's long duration. A drawback is it can't be used for high intensity exercises. Okay, let's have a little look at your table, see how you got on. I might have a few more advantages and disadvantages there, but I think I got most of them. So sport and examples then, ATPPC, you're just thinking about anything explosive. So high jump, javelin, shot put, long jump, slam dunk in basketball, strike in football, drive in golf, serve in tennis. Lactic acid system, anything that is high intensity and lasting longer than 10 seconds. So 200 metres, 100 metre freestyle, a counter-attack in football. Anaerobic system, we're looking for low intensity, well, moderate to low intensity, long duration, so marathons, long distance cycling, so something like the Tour de France. A triathlon is another good example there. Okay, and we know that each of these systems, they work together to provide energy at different points in an event or activities. So then we'd go into our energy continuum. All right. Okay. Right. I'll leave it there.